Da 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 da.
My name is Steve Condell. I will be presenting my ELR called Yenka.
Yenka is a science and math simulation software program that can be downloaded for free home use at www.yenka.com. In order to use in the classroom, though, you do need to attain a license. When you open up the software program, you will be introduced to the home screen menu. Here there are 4 subjects: computing, mathematics, science, and technology. For this review, I'll be focusing on the science topics relating to my content, physics. Under science, there are multiple topics that relate to physics: light and sound, motion, electricity and magnetism, analog electronics, and digital electronics. When you click on one of the topics, such as motion, you will now have access to a new menu on the right. In this menu, there are many different objects relating to the topic. For motion, these include grounds, slopes, balls, blocks, carts, springs, and various measurement tools and presentation tools. Under the Play Content tab, there are tutorials to help you get used to setting up your own experiments, and there are various experiments already set up for use to explore different physics concepts. For motion, these include describing motion, force and acceleration, and energy and motion. Let's take a look at one of the experiments already set up. Here we will look at Newton's second law to learn about the relationship between force, mass, and acceleration. At the bottom of the experiments, there is a short explanation on how to use the experiment, and then various properties that you can change. In this experiment, students can vary the mass of the planes and the force being applied. Students can then press the button for it to go. They can observe what happens, and then they can hit the reset button to restart the simulation. Now let's take a look at a couple other experiments that are already set up. Here's one that deals with looking at the potential energy of a spring as a function of the displacement of the spring. One of the nice features of the program is that it also allows you to modify the experiment however you want. So by clicking on the X or the Y axis, we can easily change the variable that is measured. Here's an experiment that deals with reflection and refraction. By simply dragging our angled reflector onto our experiment, we can see the waves be reflected. We can then drag our straight reflector onto our experiment, and then we can see the interference patterns that occur in this experiment and see the phenomena of standing waves. You can also create your own experiments from scratch with Yenka. Here we are starting with a blank experiment. We can add ground to our experiment by clicking and dragging on the ground. Then, if we want a cart, we can simply click and drag on a cart and add one of those too. The great thing about Yenka is that the properties of everything we place in our experiment are fully modifiable. For example, if I double-click the ground, I can modify the gravity, and I can also modify the coefficient of friction and the elasticity. The most important thing, though, is that we're able to add measurement and graphing tools to our experiment so that we can actually learn from the experiment by taking data. I added a graph and a velocity meter to our experiment. I can then tell the graph to measure our cart, and I can select from a variety of different properties to measure. We can then take our data.
I will now review the ELR. The only disadvantage of the ELR is that there is a bit of a learning curve to learn to use the program effectively to create your own experiments. It took me about 2 hours to learn to use it, which is not too bad. As you can see, the ELR Yenka has a lot of versatility and is very powerful as it allows you to create your own experiments for a variety of different subjects to fit your exact curriculum needs in terms of content and time necessary. I give it 2 thumbs up. Happy experimenting!